Assalamu alaikum, namaste, and hello to all my students. I hope you all are doing fine. And I'm really too happy because this is the first time I'm just trying to give you something in the form of a video. So I won't take much of your time in introductions, coming straight to the point. We were discussing about the chapter electrolysis, right? And I have already given you a short information of what electrolysis is. Basically, I'm just trying to go back a little bit before I carry forward to the rest of the chapter. Well, electrolysis chapter actually establishes a relation between electrical energy and chemical change. That means there are certain kinds of chemical changes that takes place with the help of electricity. This is what the chapter is, and you will have to go with the other details of the chapter. Let me go with little information that might help you if you are a beginner. I mean, if you are just starting the chapter to read. You know, there are certain elements, we call them metallic elements. They allow electricity to pass through them, right? And there are also elements which do not allow electric current to pass through them. The elements that allow electric current to pass through them, we call them conductors, and the elements which do not allow electric current to pass through them are called insulators. Now, basically, metals are considered to be conductors. So, metals, whether in their solid state or molten state, they allow electric current to flow through them. But when electric current flows through the metallic conductors, we don't get to see any kind of chemical change taking place in the metallic conductor. But you will see that there are certain kinds of chemical compounds. There are certain kinds of chemical compounds which in their molten or aqueous state allows electricity to flow through them. Okay, we call them electrolytes. Now here what happens when electric current is passing through these electrolytes, a chemical change takes place. Suppose let's say copper chloride. Now when electric current is passed through copper chloride, what happens? It gets dissociated with the copper and chlorine, right? What I mean to say is that a chemical change is taking place. So this is what you are going to learn in the entire chapter, that how chemical changes are taking place with the help of electric current. Regarding this, I already told you that you need to go through certain definitions. What kind of definitions that I already told you, like what is an electrolyte, what do you understand by electrolysis, examples of electrolytes, examples of non-electrolytes. Well, talking about non-electrolytes, I just remembered one thing I would like to share with you. I said chemical compounds. There are certain chemical compounds which allow electric current to flow through them in their molten or aqueous state. Okay, but at the same time there are also certain chemical compounds which do not allow electric current to flow through them in their molten or aqueous state. For example, sugar solution. You take sugar solution, you try to pass electricity through it, it won't flow, right? So sugar solution can be considered as an example of non-electrolyte, where copper chloride can be considered as an example of electrolyte. Likewise, there might be various examples in the book. You will get benzene as an example of non-electrolyte. You'll be getting glucose as an example of non-electrolyte, right? In the same way, you will be also having examples of electrolyte, where there are also differences between strong electrolytes and weak electrolyte. Now, basically, how do we understand which electrolyte is strong and which electrolyte is weak? It actually depends on the degree of dissociation of the ions. The electrolyte which dissociates easily in its aqueous solution is considered to be a strong electrolyte, and the electrolyte which does not dissociate easily, or rather totally, is considered to be a weak electrolyte. Now these are certain things that you need to actually go through the chapter, which I already told you before we proceed. Today I will just take 2 minutes time to discuss a new thing, right? So I'm taking it for granted that we have already gone through, as it was given in the previous notes. I informed you that please go through all these things, right? I also told you to go through oxidation and reduction reaction. Now here basically you will be introduced to one is two terms. One is basically ionization, another is dissociation. Well, you might have heard about ionization a lot in your previous class, but probably dissociation is a new term for you. Or might be that you have heard both the terms you have heard before, but you have never felt like differentiating between the two. Actually, what is the difference between ionization and dissociation? Let me tell you, ionization and dissociation are quite different from each other. Ionization basically is the formation of positive and negative ions. Positive and negative ions, or positively and negatively charged ions from molecules which are not initially in the ionic state. A molecule, it is not initially in the ionic state. When you are making it an aqueous solution, it starts forming ion, right? It starts forming ion. But when I'm talking of dissociation, I'm talking of the separation of ions which are initially present in the solid state or in the compound itself. That means the compound is already present in its ionic state. Okay, and we are separating the ions. But in case of ionization, formation of ions are taking place. Try to get the difference. In ionization, formation of ions are taking place, whereas in dissociation, breaking of the ions take place. In ionization, the ions were not present initially, they are formed in the aqueous solution. And in dissociation, what we consider is the ions were already present in the compound in the ionic state, okay, and then when we are actually making the aqueous solution of it, they are getting dissociated, separated, right? Then you might be wondering, then chemical compound in their solid state should be conducting electricity, because before that let me tell you that the polar covalent compounds, they show the property of ionization, whereas the electrovalent compounds or ionic compounds, they show the property of dissociation. That means the electrovalent compounds that we can think of, like sodium chloride, it is already present in its ionic state in the compound sodium chloride, right? Na plus and Cl minus. Then why does a solid sodium chloride does not conduct electricity? Now here you have to understand that in the ionic state, probably there is a very strong electrostatic bond of attraction between the sodium and the chlorine ions, which doesn't get separated easily in its solid state. Thus, it is not able to conduct electricity. When we are making an aqueous solution, what happens? Water helps this electrostatic force of attraction to get reduced, thereby losing the force, and then it starts conducting electricity when it dissociates into ions. I hope you have understood. Since we have to use a very short time to prepare the lecture, I'll be continuing with it in our next lecture. And please go through the chapter, because the textbook is most important for you. Go through each and every part of it. We will be discussing them as much as possible, but it is after all you who should be most serious towards your studies. Till then, thank you, have a lovely day, and take care.